So the first thing you want to do is find what A naught is. Now the formula for that is going to be 1 over L negative L f of x. So we have L given to be pi, so this is going to be 1 over pi negative pi to 0 of negative 8x plus 0 to pi of 3x. We want to integrate these, so this will become negative 8x squared over 2 evaluated from 0 to negative pi plus 3x squared over 2 evaluated from 0 to pi. All this is multiplied by 1 over pi. So evaluating this, we get 0 minus negative 8, so plus 8 pi squared over 2 plus 3 pi squared over 2 minus 0. Pi, this becomes 11 over 2 pi squared, and multiplied by 1 over pi. One of these will cancel, so this becomes 11 over 2 pi a0. In the equation though, a0 is divided by 2, so you're just going to want to multiply this by 1 over 2, so it becomes 11 over 4 pi. And that's what you put in for the equation. Part 2, what you want to do is solve for an. Just going to clean this up real quick. So the equation for an is 1 over L fx times cosine n pi over Lx. So we know that L is pi, so that's going to be 1 over pi from negative pi to 0 of negative 8x cosine n pi over L, it's pi over pi, it becomes 1, x plus 0 to pi of 3x cosine nx. So doing tabular integration, I'm going to find 8, 0 cosine nx sine nx over n, and negative cosine nx over n squared. And we're going to tabular integrate this side, sine nx, sine nx over n, and negative cosine nx over n squared. To save some time, sine at pi and sine at 0 both become 0. So we can just cancel this out because it'll always be 0. So we're left with 8 cosine nx over n squared from negative pi to 0 plus negative 3 cosine nx over n squared from 0 to pi. So that's going to become, negative here, so this will become negative. And then positive here. There's 2 negatives and then 3 negatives. That's going to become negative 8 cosine at 0 is 1 over n squared plus, again minus minus, so it becomes plus 8 cosine nx negative n pi over n squared plus, this side is plus 3 cosine nx pi n over n squared minus 3, again, cosine of 0 is 1, over n squared. Now we see that if n is even, then both of these will become positive, and then the whole thing will tend to 0. So because of that, n has to be odd, which is given by 2n plus 1. So if n is odd, then this becomes negative, and this becomes negative as well. So adding all those up, this is negative 16. Again, n has to be odd, so 2n plus 1 squared minus 6 over 2n plus 1 squared. This becomes negative 22 over 2n plus 1 squared, which is right here. Oh yeah, you have to multiply it by L, or 1 over L, so 1 over pi. And then they prefix it with a negative, so this becomes positive. For part 3, it's pretty much the same thing. We're just finding Bn. So the only difference is instead of cosine in the integral, put sine here. Sine and sine. This is sine nx, negative cosine nx, and then negative sine nx. Sine nx, negative cosine nx, and negative sine nx over n squared for n, and then over n squared. Again, these signs will just go to 0 since we're evaluating at 0 and pi and negative pi. So the only things left be these here. So this is going to become 8x cosine nx over n from negative pi to 0 plus 3x cosine nx over n, and this has to be negative from 0 to pi. We'll make this first one 0 minus cosine negative pi n over n minus 3 pi cosine pi n over n minus 0. So simplifying this, cosine at negative pi n, or cosine at pi n, is just negative 1 to the n. So make both those negative 1 to the n. Now we can combine them to get 5 pi negative 1 to the n over n. And remember, we have to multiply this by 1 over L, 1 over pi. We get 5 negative 1 to the n over n. And bring it up here. It's prefixed with a negative, so you have to add a negative here. And that's the answers.